Hello, Algebra 2. Hope you guys are having a fantastic day. We are moving on to 4.3, which is an introduction into logarithms, or logs for short. Not the log that you cut out of a tree, but the math log. Okay, so here's the thing. Logs. In the past, we kind of have taken things that you've known things about or known like a little bit of information, like polynomials. You know how x squared works, and like you know how like x to the first and x squared and x to the third work, and so we just kind of like take that and we expand it. And then sometimes we'll like take a square root function, we'll expand that to cube roots. But you kind of have known how to deal with a square root versus a cube root, because it's similar to something you've learned in the past. Logs are different because you've never seen anything like them before, and they're kind of confusing, and their rules are for logs are kind of like not like rules for anything else that we've ever done. They are strongly, as you'll find out in a minute, strongly related to exponential functions. And so the rules are kind of similar to exponential functions, but you're not going to really see that connection, I don't think, until a little bit later. So anyways, be prepared to not understand what's happening for a short period of time. I'll give you a few examples. We're going to practice a lot, so hopefully you'll feel eventually better about them, but like don't expect to immediately get it like the instant you see the video or the instant you try the lesson. It's not going to be as straightforward as that, I don't think. It isn't for most students, okay? If you get it right away, congrats, that's awesome. If you don't get it right away, that's okay. You'll eventually get it. Don't worry. Don't freak out. We'll get there. I promise. I will help you. I will be here for you and support you through all of your pains. Okay, let's move on. 4.3. What is a logarithmic function? So, a logarithmic function is the inverse of an exponential function. See? There you go. Simple. We're done. What does that mean? Okay, well, all of those things that we learned about inverse functions in the last lesson, 4.2, about inverse functions, is true for a log when you compare it to an exponential function. So, a log is a reflection of an exponential function over the line y equals x. Logs and exponential functions cancel each other out. The domain of a log is the range of its inverse or exponent of the corresponding exponential function, and vice versa. And like a 0.15 on an exponential function is 5.1 on a logarithmic function. Okay, so like all those things that we learned on the inverses, like we're going to kind of now learn for logs and exponential functions. Okay, so for example, we have this graph, right? The blue one, y equals 3 to the x, is an exponential function. You see the green line there, which is y equals x, the line y equals x. And if you were to take that exponential function and flip it over the line y equals x, you get this graph log. Okay. Now, you'll notice that it's written kind of funky. You've got log base 3 of x. Okay, so that 3 is like a subscript. And it just means that it's the base 3, which is the same base as the corresponding exponential function. If I graphed y equals 4 to the x, this would be log base 4 of x instead. And also you'll notice on an exponential function, we have the point -1, 1/3, 0, 1, and then 1, 3. And so the opposite of those points, so 3, 1 is right here, 1, 0 is right here, and then 1/3, -1 is here. So again, just shows you that they flip-flop the points. Okay, so bear with me on the definition here, okay? So for any x greater than 0 and b greater than 0, also be not equal to 0, or not equal to 1, I'm sorry. Okay. So the reason, so x has to be greater than 0, which means your independent variable, or your x, right, can't be negative. It also can't be 0. If you look at the graph of this log, right, you'll see that the domain does not include 0, right? So 0 is an asymptote, and then your log function is only greater than 0. Also, similar to exponential functions, your base has to be positive, and it also cannot equal 1 for pretty much the same reason as the exponential functions, okay? And so you would say the logarithmic function with base b is defined by the following. Okay, so y equals log base b of x if and only if x equals b to the y. Okay, so we're going to talk a lot about what this means, but one thing I want to mention is how you say logs. Okay, it is log base b of x. It's not times x, it's not to the x, it is of x, so it's a function of x. Okay, it's just like when we take x and we take the square root of it. We're doing, like, the square root of x is taking x, whatever x is, and then we're taking the square root of it. So we have x. In this case, we have x, and we're taking the log of x, okay? And so I'm going to write that down because a lot of people say it wrong. Remember, it is not multiplication, it is a function, and you are doing something to x when you take the log of it. Okay, and so basically what the log is doing is it's asking you the question b to what power, or b to the y, equals x. Okay, so b to what power is equal to x. Okay, so we think more in terms of exponentials, and so more often, a lot of the times, you're going to be translating from a log to an exponential, or from an exponential to a log. And so one of the things that helps you translate from one thing to another is something that I like to call rolling the log. Now, okay, sorry for the jump in the video. I had some technical difficulties. Anyways, so for example, to roll the log, right, if I start out with something like log base b of x equals y, I take the b, the base, that's where I start, and then I roll it to the y, which is the other side of the equal sign, and I come back to whatever's inside the log. Okay, so then what that looks like is b, the base, raised to the y, right, because b is the base of the exponent, equals x. Okay, and then the other way around, I can actually start with the base here, right? If I start with an exponent, I go from an exponent to a log, so it turns into log base b of x equals, and then you roll it back to the y. Okay, so that would be how you roll the log. I'm going to show you a couple examples of this. Okay, so these are your examples. Change the following equations from exponentials to logarithms, or from logarithms to exponentials. Okay, both of them you can roll the log, or roll the log, but you always have to start with the base. So the base of the log is the subscript 3 there, and the base of the exponent is the subscript 3 there, and the base stays the same. So going from an exponential with base 3, the log is going to have base 3. Going from a log of base 2, you go to an exponential with base 2. So, for example, this first one, I have base 3, and I'm going to roll the log. So I'm going to do log base 3 of 9 equals 2. So both of these are equivalent statements. 3 squared equals 9 is the same thing as saying that log base 3 of 9 equals 2. Okay, so try that again for the second one. So for the second one, I start with my base, log base 2 of 1/4 equals -2. right? So these are equivalent statements, that 2 to the negative 2 equals 1/4, and log base 2 of 1/4 equals negative 2. Okay, go ahead. And so the same process for the logs to exponentials. 3 to the third equals 27, and then 2/5 squared equals 4/5. And since there's an equal sign in between them, like these should be true statements, right? Is 3 cubed equal to 27? Yes, it is. 3 times 3 times 3 is 27. That's how you know that you're doing it right. And is 2/5 squared equal to 4? Oops, that's supposed to be 4/25. See, that wasn't right because I started out with the wrong problem. It should be 4/25. Hold on a second. There we go, that's better. I'm sorry, the question was wrong. So log base 2/5 of 4/25 is equal to 2. Okay, and that just means that 2/5 raised to the second power equals 4/25. So basically what the log is doing is it's asking the question, 3, the base, 3 to what power equals 27? And now what power is the answer to the log, okay? So that then moves us into the next type of problem, which is evaluating logarithms, okay? So usually what I like to do to solve the logs, this is not the only way to do it, but what I like to do is I like to take the log and set it equal to like a question mark or y or some unknown thing, a variable, and then roll the log and figure out what the exponent needs to be. Okay, so for example, I might ask you to evaluate a log, and that is really asking what does the log equal, okay? And so this log base 4 of 64, that is actually equal to the exponent on 4 that equals 64. So my process is I like to, set it equal to a question mark or y or something, and then roll the log. So 4 to the y equals 64. 4 to the y equals 64. Well, 4 to what power equals 64? 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. So the answer is 3. So y equals 3, which means log base 4 of 64 actually equals 3. It's just a really weird way of writing 3. Okay, so go ahead and try the next two real quick on your own. So log base 2 of a half equals -1 because 2 to the -1 equals a half. Log base root 2 of 4 equals 4 because root 2 times root 2 is 2. And then times root 2 is 2 root 2 times another root 2 is 4. Okay, so root 2 to the 4th power equals 4. Okay. So that's like how you evaluate a log. You just kind of figure out what is the exponent that I need. Okay. So there's two special logarithms. One is called the common logarithm. Not necessarily because it's common, but because we use it so much that it needs a special name. And the other one is the natural logarithm. And it's the natural logarithm, a good way to remember it is like the natural logarithm actually comes up a lot in nature and in natural phenomena, which is kind of cool. So I will show you those two things in just a second. Okay, so the common logarithm is log base 10. And it's so special that they actually leave the base out. Okay, so usually when we're writing a log, we do like log base 3 of x or something, right? But because if we're talking about the common log, which is log base 10, we actually don't write the base at all. So if you don't see a base, if there's a base that's gone, it means that the base is 10. Okay, so there you have the common log. Second one is called the natural log, and it's special and has special notation. Okay, all the other logs, you actually write log. Okay, the natural log, you want to write log natural, so ln. And I will explain what the base is. It's base e, which you don't know what that number is yet, so I'll explain that in just a second too. Okay, so the natural logarithm is log base e of x, but you don't write it this way. Log base e. It is denoted the natural log of x, ln of x. And so e is a number, right? So it's an irrational number. So you remember how like pi is approximately 3.14159, right? But it goes on forever and ever and ever. E is the same way. So E is another irrational number, and so what they do is they use the little e to be the notation for the number because it's a special number, just like pi. So E is approximately 2.71828, and then it goes on forever. It doesn't repeat, so it's an irrational number, but we just denote it with an e. So anytime you have to like approximate e, you can use about 2.7, just like you use 3.14 for the approximate value of pi. Okay, so go ahead, try these next examples, and try to change the equations from exponentials to logarithms and from logs to exponentials. Be sure to use your common log and natural log notation just to practice with them, and then evaluate the logs 5, 6, 7, and 7 again, which I think is supposed to be 8. Okay, so go ahead and try those. Okay, so here are the solutions. So 1, 2, 3, 4, that the natural log of 1 equals 0. 2 is log of 1 over 10 equals negative 1. E to the y equals 9. 10 squared equals 100. And then evaluate. This is 10 to what power equals 10, so that's 1, 10 to the first. 3, because e to what power equals e cubed, that would be 3. Then you have the natural log of root e equals a half, because e to the 1/2 equals the square root of e. And then 10 to the third equals 1,000. So that is it. And that's all for today. Have a great day. Bye.